Okay, that's great. This one. Okay. So yeah, welcome back to more puzzle game programming. So last time we finished an arc, quite large detour of looking into bitmaps, in particular creating our own bitmap from a font using a tool, saving that as a QOI image, writing our own QOI parser to get that into our code, then using some standard raylib functions to convert the images that we stored there into textures. But now we have these in the game. And so now I want to look back at this grid code and start, instead of having these kind of this disco floor of colors, actually to start putting these numbers on the tiles here. And then after that, if there's time, we can think about perhaps like starting work on writing like a comp time file parser. Because eventually in this game, I just want to have a bunch of handwritten levels stored as some text file. When we compile the game, the information from that text file will then just get converted into a nice format and then stored in the executable. Okay, so yeah, so we want to do, yeah, a lot of these things in the next thing I want to do in the to-do list after getting stuff running is this thing here. Stuff like doing the randomized puzzles is really for the very end. Only once we've actually got everything else working is it time to do that. And likewise for a main menu as well. We've kind of got, we're switching between two menus at the moment, but yeah. Okay, so let's go down to the tile stuff. Yeah, we want to start drawing some. Let's have a look at what the render code currently is, and then that will be a good position to think about how to start adjusting it. Okay, so we have two different render functions, both for the menu screen and this screen. This is the one to focus on today. So, so currently we're just drawing, say, the background, and then this is the current kind of tile drawing function at the moment. Given this grid, and actually where even is this grid? This is something that we're passing into render puzzle. Okay. Okay, so this is the grid here. So yeah, so given all of these tiles, which are just 1/8, we're simply choosing the different color of a rectangle and then drawing those. Okay, so let's replace this with just a general draw tile function / procedure. And instead of just drawing a separate color now, it's going to be drawing one of these textures. And I think for later on, and I think it will be useful for this function, for this procedure, to just, when we call this procedure, we just we call it with one of the tile types, and then it just draws the tile of the specific type. Okay. I'm thinking also at this stage, since the rendering in this app is slightly more difficult than like the butterfly app, given that we're going to have a bunch of stuff, it might even be useful to start a new render file and then start kind of just like segmenting the code out a bit like that. Yeah, why don't we do this now? Let's create something called render zig, and then to do migrate the render code from main over here. We'll do this a bit later though. for the moment, let's just make sure we're importing this. Ooh. Because Zig projects are slightly different from Odin. So in Odin you can have several different files, and you don't need to do any of these like specific import stuff from different projects. Everything, when you compile it by default, all code across all files in any given project works. I could do something like this. I'm just wondering if this is actually going to be a bit painful. You know what, okay, I actually take it back. Let's just try keeping everything in one project for as long as possible, and then if it becomes unsustainable, we'll move it over. Just because I'm unfamiliar. Like, I know in Odin, in the Odin programming language, it's really trivial to deal with the mess because there doesn't really become a mess. I'm slightly afraid there may be a mess in Zig. Okay, let's just go down to the bottom then, and start writing. Okay, so let's say we now write a function called drawTile, and this is simply going to take in something of size tile and not return anything. For the given tile type currently, it's just a single number. Yeah, I think this is, oh, we've even annotated this, great. So 0 denotes an empty tile, positive number represents a fixed tile, negative represents a selected tile. Okay, so potentially we're going to want to display both the tiles that are fixed and the tiles that are movable in slightly different ways. So perhaps if one way we could do this is just like changing the background color. So perhaps if the background color is, if the tiles are just black and white, it's a fixed tile, and then if the background is maybe slightly gray, it's a movable tile. What's another option? Another option could be using a different font face, but I don't particularly like that. It could be a different font color. That would involve changing the textures a bit, but it wouldn't really be too difficult. Let's just go with the background color since that's easy to do to begin with. Okay. Yeah, draw a specific tile. Yeah, you say draw both draw tiles both those that are fixed and movable. Okay, in addition to the tile, we also want a position. Okay. So really, where should we begin? I think we should just start with the switch statement, really. We want to switch on the tile. And so we first have these options. Let's start with the options that are fixed first. Okay, so we have this one that's fixed. And likewise 4. And then T, right? Okay, so we really just want to be calling, we want to know what the side length of any of these tiles are. This should be stored as a global. Tile length Oh no, we haven't actually made it a global. Square length plus bar thickness. What are some other places of this? So it's just here. Yeah, okay. Why don't we move this to a global? The other option would just be adding in the length function here, but I think it just makes sense to set these lengths at the beginning of every frame when the geometry is calculated, and then things are just stuck. Okay. So we'll label this as D, and then we'll come back to it later. Yeah, I think we really want to set it during this part. Like, we don't yet have a part in this where we're computing the geometry. I kind of want to add that in now as well. Yeah, this part, not doing that much. It simply is doing what it says. It's processing the input, updating stuff. So why don't we just do something called calculate geometry. And then this is where we will set a bunch of the globals. I mean, aside from these ones here, which are used everywhere. But yeah, set calculate the sizes of much of the global geometry. Okay. Okay, so part of this stuff, there's a question to be made. What stuff in here do we move to global? What stuff do we just leave in here? I feel that a lot of stuff can really still remain in here since we won't need to use it for later kind of functions. This said, for some of the stuff like the mouse, processing the mouse input, that's going to involve stuff like clicking on this grid. And so when we eventually write that stuff, we are going to want to know where the mouse is relative to all of this stuff. So actually some of the grid geometry should be moved to globals. Why don't we just go through it one by one? I also need to refresh my mind of what's happening. Okay, so we set this grid position, and then hopefully stuff is set relative to this. Minimum screen dimension. Oh, a lot of stuff is set relative to even this thing. Okay. I feel like this should be a global then. And yeah, this is going to be updating each time. So then let's make sure that we do find So if we go to main, and then I guess we can do it in the update geometry actually. I kind of want to put it here though. It is quite important. Okay. And then, okay, do that. It's been set, that's been set. Okay, all of this stuff is temp. We will replace that tonight. So yeah, this TL square, so this means top left square position, and then we are doing it relative to grid pos. Okay. So we are going to need to know this kind of stuff for the mouse clicking interaction stuff. Maybe we should actually store this stuff in like a struct and then move this into the globals, because we kind of do need all of this. Like, I think it ultimately depends. We could be a bit lazy and just say when someone clicks on this, we could, not lazy, we could be I see two options, either being precise or lazy. In the precise option, if someone were to click on one of these bars and one of the tiles near it was actually clickable, in the precise version nothing would happen. In a lazy version, clicking on the bar would just select the tile kind of closest to it if it's selectable. I feel like we can be precise, and so there's no reason not to be. Yeah, we'll go with that. So really all of this stuff should be moved then. Okay, yeah, so that, yeah, to put it another way, when we do the mouse input, when someone clicks, we will need to check if that click is within one of these squares. In order to do that, we need to know where the center of any of these squares are. The center of these squares currently determined in a loop via this. We calculate this position as an offset from this and then do stuff with it. I kind of think it would be easier if we actually just have a fixed array of 16 vectors, and then we simply calculate the geometry of all of those in the geometry part, and then we can use that array in both the click selection and the rendering. Yeah, let's do this. Okay. So to do this, we need to set up another global. So I say like grid geometry as well. Geometry. Okay, so why don't we say tile just like tile positions, or rather like grid tile positions. So this will be fixed array of 16 vectors, and initially undefined. And then let's now fill that up in the calculate geometry part. What should I call this? Like, call it 1. So yeah, grid tile positions. We want to initialize this. So we want to say for let's say for the yi in 0 to 4, and then for the x indices in 0 to 4 as well. We want to set the grid tile position that is 4 times the yi plus the xi, and this is going to be something. But in order to even get to this, it's probably better like that. In order to even get to this, we need to know we need to know a bunch of things. The center of this grid, the width of these tiles, and then the width of the bars. So let's go back down to the render part then. I really feel like this stuff we should store this stuff as a struct. Although we don't actually, there's some things we don't need. So yeah, we won't need this part for the drawing anymore. So that's actually just this just feels really complicated. Clearly it was a late night when I was drawing this. I don't think there's any harm in wrapping this in a struct, so let's just do that. What was it, like 1? Okay, so let's make some struct called like grid geometry. Let's even well, yeah, it's a bit separate from the grid tile positions, but otherwise. So why don't we do like grid, who am I kidding? It's easy just to have it as a single thing. Yeah, this is fine. Okay, grid geometry. Oh, no. How do we do this? We want to say constant grid geometry variable geometry is equal to a struct. Okay, and then the important things. So let's kind of insert all of these here. So yeah, the most important thing is the grid position, and we want this to be a vec2. Then we want to know the I guess just the square length is the next most important thing. It's just an F32, and then the bar thickness as well. This total length we kind of can ignore though, but does it actually hurt to leave it in here? I'm just going to take it out now. Maybe we don't need it. And then finally, one of the most useful ones. This. Okay. Now we have that. We can call it at many stages. So now let's calculate all of this stuff. So in particular, we now want us to say so this is a struct, but we kind of need a how does this work in Zig again? I guess since this is a type, we need to substantiate it. So actually, we want this to be a constant, and then we just want to say variable grid geometry is equal to has type grid geometry, but it's going to be undefined at this point. So now let's set this stuff. So I can now set, pardon me, that this grid position is just this thing, macro time, grid geometry dot equals all of that. And then okay, now we can finally do this part, the grid tile positions. Let's remind ourselves how this part previously happened. What did we do? We did... Alright, let's just make this full screen again. It's so much easier having two panels than the other way around. Yeah, so we simply just iterating over iterating from 0 to 15 inclusive. We just like broke down what each of these were, and then but we actually first calculated the top left square position and then did other stuff. Okay. Is it even worth just storing the top left position? No, since we only really need to know that insofar as calculating the other stuff. So it's fine if we don't actually set that. Okay. So let's just then copy that line over here. So we have this grid geometry, and we take the grid position, subtract from that half of I'm just currently debating should we assign all of these local variables and then update the grid geometry with them, just to make the code a bit simpler to read. I think so. Yeah, I'm feeling this. Okay. So I'm going to say const all of these things. And now I want to say, well, now we want to set the grid geometry to these things. Yeah, like grid. We want to do grid geometry dot this is equal to the grid pos, the square length, the bar thickness, and then the total length. Okay. Now we can leave this without having to append anything to the beginning. And then now we've got that, we then need to calculate these tile positions. And so going back down to the render stuff, we use this one. We take this top left square position and then do some stuff. Okay, yeah. We're going to have to convert each of these uints to an F32 first. That's a bit of a pain. It's inevitable. Yeah, so why don't we just say here, it's a bit simpler in this case. XI float and YI float is just as float from int XI and then float from int YI. And then for this part here, hopefully we can just copy this and set this one here to be the rectifiers. Hello, how are things? Two-step. Let's make this the tile position. Okay, yeah, top left position, then we're saying go across from here, XI numbers of the square length. Square's a bit vague, I kind of want to call this tile length instead. Yeah, let's just replace all notions of square underscore with tile. Square underscore tile underscore. Yes, 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 yes. Yes, 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 yes. Yep, yep, yep. Yep, 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 yep. Okay. Oops, where were we? We're here. Okay. So then we should have set all of these grid tile positions, and so yeah, my day was busy, but it was still eventful. Like I went on a walk with a friend, went and saw a film, got a lot of programming done as well. So yeah, I can go to sleep knowing that I've done a lot on this weekend and had fun. And yeah, this programming is more fun than what I was doing earlier, which is good as well. Yeah, so in terms of the project, I'm just rewriting, I'm simultaneously organizing the code in future for later stuff, and in the process drawing the textures that we broke up last time on the tiles instead of just drawing them as color tiles at the moment. So yeah, so currently I'm just calculating the geometry of a bunch of these tiles so that later when we do mouse processing, like when I click on the screen, I need to be able to know if I'm clicking on one of these tiles. So yeah. Okay, so then I think this is most of the geometry calculations done, and so I think we can start replacing this kind of stuff. Okay, so let's do this. So this background length is just now going to be the grid geometry total length minus the grid geometry bar thickness. The rendering is going to use a lot of these numbers again. So let's just make a bunch of local stuff again. At the very top. Okay. But now this time, like the first time in my life that the line regex command has actually been useful. Now I want to do this, and then we want to now do grid pos, tile length, bar thickness, and total length. Okay. Now I can use a lot of these as before. So now this background length is just this total length minus the bar thickness. Why? Okay, I guess like what is the total length again? We're saying 4 tiles plus 5 of the bars. Okay, so maybe we're like subtracting the bar thickness to like subtract half a bar on each side. Okay, maybe. Hopefully. Okay, done that, and then here we're actually drawing drawing this background with a grid fill color. A bit surprised this isn't, say, like grid background color. Let's just check this out. Grid fill color. Maybe this is okay for the moment. Okay. Then drawing the not empty tiles in the grid. Okay, so now we can actually go back to this function, this procedure we started drawing initially. This kind of draw, is it draw tile? Yeah, okay. So we can clear out basically all of this. Now that we've calculated these rectangle positions, we don't need that. We've already calculated the tile length as well. Yeah, okay. So now for here, we just want to say for yeah, for the tiles in the grid, we just want to call, let's index these. Call it like the tile index. We now just want to call the draw tile function on this tile, as well as the tile position. This tile position is going to be given by looking up in the grid tile positions the index. And that should be all we need to do now. Once we actually finish writing the draw tile function. Okay, down here. Okay, a bit of a detour, but now we're back here, and we fixed things in the process. Probably. Okay. We should also just have like an else case as well. Okay, so now we can use the textures that we developed last time. So these numeral textures are all of these, and good thing we made them a global. So before you even draw anything, we need to know what the length of the tiles are. So we have the grid geometry tile length, and then we want to switch the texture that we're going to draw using this kind of stuff. So why don't we then say your variable texture is okay. So if I was programming this in Odin, I'd probably say something like texture is equal to this, or like undefined. But since switch statements in Z can return stuff, I can just use that instead. So I can literally just say the texture is equal to, I should probably say tile texture is equal to switch on this. And then in this case, I can say, I'm like halfway through writing this switch statement, but there's actually an easier option that doesn't even require a switch. So let's just do this. Let's first of all just take the absolute value of the tile, since the tile is just an I8 anyway. Ooh, is this from like the very first project we did, an absolute value intrinsic is not yet in the compiler. Yeah, so we have to, we'll just use like the crappy version from the last app that is not the sophisticated Hacker's Delight version, but whatever. There it is. So let's just say then, this is, okay, I really should be making this more general instead of an F32. I know we can do this in Z. The question is how. Can I actually do it like this? We'll see. The point is, I just want to say, take the absolute value of the tile. These are now, and once we've done that, subtract 1. Now we have the indexes that we want to use. I'm committed to this now, even though the switch statement is a lot easier to think about. It's okay. So now we need a usize, and now we need like int cast this. No. yeah, this. And now I just want to say the tile texture is equal to numeral textures, this thing. This seems a bit silly. Say texture index is equal to this, and now the compiler will optimize this out. Okay, now we do that, and now we want to draw a rectangle in the given position with this. So now it's simply draw, what is it? Draw, okay, so yeah, so two steps suggest, isn't there a standard.math.absolute value in 011? Possibly. It was probably the case that when I was searching the documentation last month, whenever it was, I didn't search it particularly well. So the recommendation is in the math library, something for absolute value. I'm seeing these in the big int library, but not in like the small one. Yeah, unless I'm like missing something. We can always check it out. Zig standard, zig lib standard math.zig. I do like, okay, there's an absolute integer. Oh, I guess that's what I should use then. Okay. Oh, wait, no, why isn't this searching? Why isn't this coming up in the search results? Oh, it's because I'm within the math library itself. Oh, okay. Here we go. Here's all of them. Yeah, these are... Oh, there's even like a absolute value and cast at the same time. Okay. Abs cast. Returns the absolute value of the integer parameter. Converts result type to unsigned if needed. Use abs int if you want to keep your integer type signed. No, I don't want that. I think this is what I want. If this is actually going to, yeah, this looks like this is, oh, hang on. We're not using comp time ints here. Yeah, so how does this work? What's int info? Something, okay. Yeah, if it's unsigned, I'm learning a lot about the typing systems in Zig as I'm reading this. See, if it's already unsigned, which is not in this case, return. Otherwise, meta in info bits, okay. And then, oh, here's like the hacker's delight way of doing it, maybe. Okay. We can just, oh, there's some testing cases down here, great. So yeah, if it's -1, we want it to be 1, indeed. If it's like -99, okay, this, great, I understand how this works. Okay, thank you for another excellent suggestion, two-step. Yeah. Away with that ridiculous absolute value function code. So here, instead of all of this, I literally just want to say standard.math.abscast. What was the number before? Oh, just the tile. Okay. Okay, and then I kind of want this to be of type useSize though. Actually, so maybe if I just say it's as useSize, then that would work. Okay, assuming that works, we've now actually got the correct index. Oh, once we subtract 1 from it. And then, even before we do this though, we shouldn't be drawing, hang on, if the tile is 0, we don't want to draw it anything, so we just immediately want to exit. So if tile is equal to 0, we just return it immediately. Otherwise, all of this stuff. And now we want to do the draw rectangle function, where surely it was just called draw centered, right? Draw centered. Rect, and so yeah, we pass in the position, the width, which is just the tile length. In other words, the length. The length, again, since it is a square, and then finally the color, which doesn't matter. We do need to think about this. This part does matter. So yeah, so we'll say like fixed tiles have a, say like solid background color. Movable tiles have a transparent, have like the usual background. No. If we're actually moving the tiles, we actually want to assign them a color. Okay, so why don't we say like fixed movable tiles have different background colors, namely if it is fixed, we want something, and then if it's movable, we want something as well. We'll decide what this is slightly later. Okay, so two steps says the as useSize isn't needed, gets coerced to useSize when you index with it. Oh, okay, good to know. So I'll leave it at that then. I still, okay, I'll just write useSize like this then, and then it's still just clear for me reading it what it is. Okay, even if perhaps this isn't necessary because it's still determined that way. Okay, let's assign some of these colors now then. Where are we storing these colors at the moment? Up here. So we have a grid fill color, and I guess this is the one we want for maybe the movable ones, and then for the fixed one, we'll give it some other color. So why don't I say we'll give you these different colors. Tile. The tile fixed background color. Yeah, this is fine. Tile fixed background color, and we'll make this maybe like dark gray at the moment. And then for the movable option, we'll make this whatever the, say, the grid fill color is. Okay. currently, since everything is alright, actually let's make the movable stuff debug. I can't make up my mind, and currently just make this the grid fill color. Okay. At least by making this debug, when we do come around to it, it will be immediately obvious that this is something we need to think about and change. Okay. Sorry, doing this was unnecessary. The colors are these specific color choices. Yeah, globals. Okay. But we need to remember. We need to just determine the type of this. I guess we can do this with a with one of these like ternary expression things. And it looks like I forgot a. There's an actually bracket there. Okay. So I'm going to say tile background color is equal to if the original tile is positive, it's how does this work again? Positive numbers represent fixed tiles. So then it's fixed. So then, since it's fixed, we want to be sending it the fixed background color. Otherwise, the other one. Otherwise, the movable background color. Okay. We're getting there. So now when we draw the centered rect, we can make this. Okay. We're already in a tile function, so we may as well just call this background color. And now we actually need to draw the texture, the main thing. So now we need to call our texture drawing function. Draw texture. So I want to say draw texture, and then at the tile texture. And likewise, just send in the position. Oh, we need the height, but the height is just the length. Okay, and then we should be done. Okay. This is going to take a while to fix the compiler errors, but there will be lots of progress. So now we're going to have to do zig build. Let's run it. (116). Okay. While we're at this, let's just do that. 237 expected return type expression. This isn't returning anything. 255 use of undeclared identifier grid tile positions. Did we not set this as a global? Yeah, we did it. We wrapped it up inside our grid geometry. Okay. But we didn't mention it up here, so let's do that. Well, I guess we actually we don't otherwise need this, so I guess we, wait, what? No, this is, no, we do definitely need this here. Okay, what's this one? A 253. Unused local constant. So these ones here should just be XIF and YIF floats. 327. Grid tile positions also confusing. That is okay. Now we can just say that these grid tile positions is equal to the grid geometry. The grid tile positions. Okay, 416. The local constant shadows declaration of background color. Oops. I guess I really should have left this as tile background color. What's this one? 246. No field name total length. Instruct main grid geometry. Really? Yeah, I regret not adding in the total length. This was silly. Let's just add that in now then. And we just want this to be a float. What's the next one? 419. Type error thing. Well, let me call this tile texture pointer, and we just take the pointer to it here. Then here we can just say tile texture pointer. Hey, and it's working. Great. Excellent. Let's just make sure I haven't done anything dumb with the forgetting the orientation of like the y-axis or mapping. If we go to grid 1, do these match up. 1, 2, 3, 4, 4, 3, 2, 1, 2, 1, 4, 3. Great. Things seem to be working. Let us save this then. Yeah, things are working. So now we want to do git status. Yep. I thought we basically deleted. Let's delete this render.z. Yeah, and now we can just say got our bitmaps rendering on the tiles. Did massive code. It wasn't massive. Started moving geometry calculations into separate procedure. Okay. Yeah. Push this to the cloud. Okay, let's see. The time is now midnight, so I should be getting to bed, but I cannot help myself. I want to do more. Okay, so what can we do next now that this is working? I'm happy. Like this was, It took us a while to get here, but now we're here. I am happy. Okay, so so I guess we could actually get started on this comp time or even runtime. No, let's avoid the runtime. Passing of a puzzle list. I think even before we get to this point, let's just play around with this grid at the moment. So say I make this 0. This should give us like pink square in the corner once we build it again. Sometimes I think pressing the up arrow will just... Okay, it wasn't pink though. I guess this is because when we take the absolute value of 0, we just get 0 again. I guess that's actually... Ooh. No. We do want this to be a debug color. Okay. Empty tiles should get the background color. And the... Actually, this is fine. We're doing this immediately. Let's just add that comment in. Or rather, empty tiles should not get drawn. Okay. In either case, the texture isn't drawing, so it's fine. I don't know why I thought this would be the debug color. Anyway. Okay, back to the massive to-do list. Actually, before we kind of implement this, I think it would be good to think about the kind of logic of how stuff is going to be dragged around, how a puzzle will be validated towards a win condition, these kind of things, since this will ultimately determine how exactly we do like a comp time passing of stuff. Okay, so that does feel like several hours of work. Maybe there's a simpler thing we can do for like another 20 minutes. Think about buttons, and just rectangles. This also feels a bit complicated. Main menu is kind of a bit... All of these are kind of hard things. Okay, an easy thing to do would just be to write some procedure that tells you when a given grid has been solved or not. But even actually thinking about how this logic is going to work, I think we should actually think about this game logic now, since this is really going to influence the rest of the project going forwards. Okay, except for maybe the main menu, but I don't like particularly want to do stuff with that right now. Since the main menu will involve clicking buttons anyway, and so when it's time to do the buttons, we can do that then. Okay, so we're currently just passing in this grid 1 when we're rendering this thing. Our render function is just literally switch the game mode. If it's these handcrafted puzzles we're making, render this, do the render puzzle function with the grid. This kind of seems a bit silly actually. I feel that like the current grid should just be some game state level thing. Like we have some global that just says this global is the current state of the grid, and then we can update it as necessary. You know, when people like drag some tile onto here, swap a tile using the arrow keys, mouse, whatever, the keyboard, whatever, that thing is updated, and then maybe resetting the puzzle just means means like completely reloading that with whatever the concrete starting point was. And then likewise, yeah, making a puzzle game without an undo button is really silly. We'll need to, let's just add this to the to-do. Don't forget an undo feature. Like if I'm playing a puzzle game and for me and it doesn't have an undo feature, almost always I just immediately quit the game and don't play it. Especially if it's like a circuit bind kind of thing, it's infuriating. Yeah, so I think just having like a list of having just a struct which is like the core puzzles, and then a list which is like the current kind of live states of them, and then if those are okay, yeah, let's start writing code for these ideas in my head. Okay, so after all of these globals, probably actually maybe these don't seem to be arranged in the best way. The very first global should be the game. Okay. So yeah, the game mode, and then now let's have what truly will be a compile time constant, which is the handcrafted levels. And at this stage, we are going to want to call like a comp time function that loads these. To do write set this to the result of the comp time level parser. However, for the moment, we just want this to be, let's make it literally an array of length 1 using the grid the example grid we did. Okay, so what is this grid 1? Yeah, this grid is just something of tiles. Okay. Call this grid 1. Does it actually make sense to have these globals before the types? I don't think so. We should move some of these up. Yeah, let's move all of this stuff upwards. Yeah, since these types of these things above it, we'll move them up here. Okay. Okay, so now we've got all of that. So back to this. Yeah, we've got that. And then we also want a variable list of the current versions of these handcrafted levels. So we want to say maybe I just say current levels. But maybe current levels is a bit too close to current level. Let's just call it current handcrafted levels. And then initially when we set this, we want this to just actually equal these handcrafted levels. I want this equal sign in Zig to just actually copy all of this data over. I don't want this to be a pointer. Hopefully it's not, given that everything is a fixed array. I just want to quickly check this documentation. Okay, that would be too tedious. Let's move on with it. But just I'll just add in a note, like the equals sign below should really be an actual copy, not a pointer. Okay. I mean, yeah. I mean, if you're still listening to Steph, yeah, if you could chip in and say, yeah, this equal sign here is actually just going to copy all of the data here, that would be useful to know. Like, if not, we could, a workaround would be relatively simple. But yeah, this should be fine. Okay. Okay, so then when we're actually playing the game, we're going to be updating these handcrafted levels, and then, but we still need a copy of these. For instance, if someone says reset the level, we just want to immediately set whatever version is here and here. Okay. We should also have an index of the actual current level. So why don't we say current level index, and we'll set that to be 0. And why not just, for maximum unambiguity, call it current handcrafted level, and we'll make this 0. Oh yeah, Two-Step says, okay, sorry, not sure, understand. You can get a value from a pointer by dereferencing it. Yeah, for sure. It's just for this one here, I want these handcrafted levels to be in different memory locations than these ones. Like, maybe the compiler will already ensure this anyway, given that this stuff is a constant. But yeah, when I modify these ones, I don't want these ones to be modified at all. Like, these ones should just remain constant. This should just be some data in the executable that might even get optimized out at compile time. That's just what I mean. Because yeah, like in Odin at least, if you have a fixed array and you have an equal sign, you then just copy all of the data over. There are some, whereas at least in Odin, if you have a dynamic array, for instance, most of the time I think that is actually just a pointer. Okay, so now we've got those. Is it even worth actually thinking about some of the game logic at this stage? Or even implementing that? No, we can wait until we do buttons before we start flipping between these two. Let's just, for the moment, I don't want to do it though. Not yet. Even if we don't do a whole lot of button stuff now, we can add in a really crude button that will just flip between different handcrafted levels. And this will at least enable us to get started on making sure the logic for going between levels is alright. Yeah, it's... Oh yeah, so yes, it's just as saying, pretty sure that's already happening there. Arrays of values in Zig. Maybe you're mixing arrays and slices. Yeah, I think I may be. Okay, maybe I can get rid of this. I'll get rid of this kind of note then. Yeah, given that this is a constant here, yeah, I feel like already the compiler will be okay. But okay, yeah, moving on. Okay, so let's actually just make 2 handcrafted levels at the moment then. Not that any of these are going to be in the final game. This one here. So yeah, let's make a grid 2. And yeah, what should I do with this one? Like, let's make most of this one empty. So maybe the top line in this is completely empty. Maybe there is a 4 here. Maybe that's a 0. I guess I can use the insert button on the keyboard. Maybe that's a 0, 0, 0, 0, 0, 0. Okay. These parts are done. Do that. It will be useful to just keep track of the number of these handcrafted levels as well. I guess we can actually just do this dynamically. The number of handcrafted levels should just be the comp time length of this. Yeah. The compiler should give an error if it doesn't know that. Okay, but otherwise, let's use this this information to slightly redo the the current logic. Okay, so we'll move this up here. So if we go back to the render stuff, instead of, we shouldn't really need a grid at all. I guess we can actually just get the grid from this global. So I can just say the grid is equal to the current handcrafted levels and then the index and the current handcrafted level index. This is a really big name. It's okay. We're not going to be using it that often, I think. Yeah. Okay, now I've got the grid, and so the rest of the stuff should be the same then. But yeah, let's get this up slightly. Okay, let's see if this now renders, compiles. No, 308. Yeah, no need for an argument there. 115. What? Variable of type comp time int must be constant or comp time. Oh, yeah, okay, I see. I mean, since this is an index, it's going to be of size. It's going to be of type of size. Okay, that compile. Okay, so now let's just add in a kind of hacky move to the next puzzle situation, where we'll add in some like square which will act as a button, and then actually not even that, maybe just clicking will advance to the next, yeah, the next puzzle. And then we'll turn that into, clicking will just cycle between the main menu and all of the screens at this point. So mouse down, here it is. So yeah. So if we're in the handcrafted section, we'll go to the main menu if we're on the last puzzle. Otherwise, we'll increase the puzzle number. So let's just say, so we want to say if handcrafted if the current handcrafted level index is equal to the number of handcrafted levels minus 1, then we want to return the main menu. Otherwise, can we return from a switch statement? Possibly. Let's try. Return dot main menu. Else return. Otherwise return. Otherwise increase the. We actually don't just want to return. We also want to increase the level number. Really, we want to set it to 0 again. Reset it back and then return to the main menu. Otherwise, increase it by 1. Yeah, and then hopefully that's kind of all I need. No, it didn't like this. Why? 292. Yeah. Okay, we can't use this return in a switch. Okay, so if we're in a switch and we are branching in the switch, and this switch is returning something, how do we get one of these back? Is it just continue? Yes, you can return from a switch. When you return break continue, the expression gets type no return. Oh, maybe I did misread the error. Okay. I probably did. Expected type void found type of return main menu 292. like I can, so like most of the statements here are like that, and now I'm just saying, kind of switch on this. Oh, maybe I did mean break main menu. Let me just check out the documentation again. So this also helps me to learn. I see. You do need to use all of these breaks, and oh yeah, some of these breaks can also be, and it like breaking to specific places. Okay. Which can also go over tagged unions. Oh, you can. Yeah, it automatically does this by default. Yeah, there's a comp time version. Okay. Okay. Let's try this. No. Break expression outside loop. What? Oh, okay. Yeah, I probably do need to add a label. Maybe there's actually an easy way of doing it. I'm just saying, if the game mode is this handcrafted puzzles, just determine this condition and run some extra code and then return something different depending on this case. Maybe actually this isn't the place to do this. But I kind of feel like it is though. Because okay, this also isn't something to massively fuss over. This is just something to help. This is not going to be in the final game. This is just something to help with testing out this stuff as we build it. Okay. Okay, yeah, so I should just add some labels. Okay, so to this block, let's add this label then. Okay, so why don't we just call this like label 1, a very creative name. And then here I kind of want to say break to label 1 main menu. Else this. Okay, we'll give this a go. Expected expression or assignment. Maybe I can go back to the documentation and study an example here. How does the break stuff work? Okay, yeah, so this is a case where multiple lines is happening, and this very final line is break, label, and then some value. So I'm saying, yeah, that's what I thought I'm doing. Branches can be arbitrarily complex. Yeah, block. This is this break blah. Okay, so maybe then and maybe instead of label 1, I literally do call this a block. Then perhaps here I say, maybe it would make sense to put a break in both of these, and it's just in this case we're not switching this at all. We're leaving this on the handcrafted version. Okay. No, still doesn't like this. Why? Is there something wrong with the parentheses? Expected expression or assignment found colon. But I'm tagging this in a block, like the examples. 101 goes to, the tag's meant to be on the right instead of the left. That's really subtle. Okay, now I know about it. Okay. Aha, great, and now clicking cycles through these different ones. Okay, let's save this, and then I'm going to call it a night. But this functionality now immediately means we can start testing. We can write a function to like validate whether this is correct or not. We can start now adding in some buttons to go, say, left or right between these levels. Then we can start doing menu stuff, and then actually the menu stuff is not important. That can wait until like the very end. Yeah, we'll add in buttons to go left or right. Once we do that, that should also give us the ability that will help us in like dragging these tiles around, and then actually maybe even before we do tiles, we just figure out how to play this game with the keyboard. We'll figure it out. We will figure it out next time. Okay, so yeah, what did we do? We just added in more grids. Yeah. Added in like another, started adjusting logic to deal with multiple grids. Levels. Kind of like what did we even call them? I'll say it's like hard-coded dynamic levels. Okay. Yeah. Thanks. Yeah. Thanks as always, everyone who came along, joined in. Thanks so much, Two-Step, for the sage advice as always. And yeah, like already I'm still writing like the Hive, doing from scratch image decoding, and now having that in the app. I imagine like many months from now, when we start looking at Vulkan, I will feel a similar way. Like the first time that we load a QI image and get that rendering on the GPU and actually start dealing with that side of stuff instead of currently sweeping it under the rug with Raylib. But yeah, all of that in the future. But yeah, and see you later. Bye.